why is Docker interesting? Well, a lot of these technologies have existed in bits and pieces before, but Docker is a semblance that has kind of some focuses which are really interesting and make it particularly powerful. The first thing is that a lot of things have been focused on simulating an entire computer with all of its processes within it, with all the services and all of that stuff. And Docker says, no, let's just simulate enough that we can run a program in there in an isolated environment. We don't really need all of this other stuff. We just need that program. When we're firing up that virtual machine, all we care about on the web server is HTTPD, or Apache 2 if you're in a Debian-inspired universe. When you're firing up that accounting system, all you care about is, name an accounting system, PeopleSoft. All you care about is PeopleSoft. The kernel, the services, the little, ding, it's time to, all those things, you don't care about that stuff. That's not helping you do your business. So Docker is written with that in mind. It's like, what you really want to do is isolate programs from each other. You don't really care about the other stuff around it. It's designed to be very portable in that what the idea is that you're isolating the program and the things it needs. Anybody here use Curelet? Raise your hand if you, yeah. So, make Curelet, right? You feel like, oh, I forgot that library. Oh, I forgot that. So this is satisfying that requirement that, that you have this container, you have a program running in it, and everything that program needs is in that container, but nothing else. Nothing it doesn't need. You have this automatic build process, so you can kind of script how Docker containers are made. So that way, when you do your apt-get upgrade or whatever, if you need to build another one of these things with updated dependencies, you can kind of go back to the recipe and say, go again, and you get a new one. It also means that if you want to share stuff, this is kind of like building from source packages. It's like a make file, except the make file can download stuff from the internet and things like that. You can just send somebody, hey, here's the Docker file and the support files for it. Hit build and boom, you'll get the same thing I've got. And so you don't actually have to ship that much, generally speaking, and you can replicate an environment perfectly. You have a really high level of reusability. Remember how AUFS allows you to layer things up? So rather than talking about dir 1 and dir 2, or file system 1 and file system 2, imagine base install of Ubuntu. Base install of Ubuntu, and then a change layer on top of it that says add in Apache, and then a change layer on top of that says no, change the layers below me to tweak it to add a WordPress to that Apache install. So you start, and now each of these layers, all they contain are the changes, just a little bit of changes, the little shims. So you get this really high level reusability. You can use the same baseline in a lot of different products, and the only difference in a lot of cases is just a text file that describes the changes that needs to be made to build that next layer, to build up on the next level. So huge level of reusability. It's really easy to share. Docker supports this public registry. Like you say Docker pull Ubuntu. It downloads a copy of an Ubuntu runtime environment. Docker pull WordPress. You get a WordPress install. It's kind of silly how easy it is. Now, before people get too kind of like, well, but I don't want to publicize my stuff, very easy to run your own Docker repository, as they call it, and to publish stuff to your own repository, a private repository, and interact with it. So I haven't done that, though. I'm saying very easy from what I've read, so anybody who's got experience, you can correct me. But it allows you to share between computers, between people. This is the great thing about packaging. People used to, not for long, mind you, but used to have to compile it themselves. They wanted Linux, and now we share in the repository of pre-built packages and we download them. Well, this is pre-built services with their dependencies attached to them, which is pretty neat. It actually has a pretty good tool ecosystem, so it means that you can take Docker and you can automate it with other things. It has an API, so you can say, hey, spin up more of these widgets if I need them, and shut them down when I don't need them, and go ahead and start like these 6 containers, with one with a web server, 3 with a web server cluster that I need for simulating a high availability environment, and a couple for front end servers that that use that backend. And you can say go, and it's just it's actually, it can be as simple as 2 files. Did you have a question?
I have a question about the portable deployment point. It seemed that you're offloading a lot of the differences between what's going on in your containers to the host hypervisor. I don't know what the terminology would be here. The host operating system. You have this definition of what's going on in the container. How portable is that between different operating systems that host the containers?
So it's portable to the degree that it's, for example, I can spin up a CentOS environment that CentOS applications will run well on, provided that there isn't drastic kernel differences that the application depends on. Most of the time, when you can't install a package on a machine, it's it's just because the file system layout and the service layout and the service manager are a little different between each other. And so I don't know if you've ever done this. You fire up Alien, you can take the RPM, and it'll often just sort of work, except you have to fix the library directory or something like that. So Docker has that portability that you can fire up a very good simulation of CentOS and then install CentOS packages in there. And when you call customer support, you can say, "Yep, I'm running on CentOS."
Well, let's go down a layer though.
It's the same kernel.
If you have Windows on Mac,
It's not portability across operating system. This is a Linux-only solution. So absolutely, this is Linux kernel and nowhere else. You must run on a Linux kernel for this to work.
But between distros, if you install a container, like you said, you install a Ubuntu container, that means that your host libraries aren't being used at all, right?
Indeed.
Okay.
Yeah, you can install a Ubuntu container on a Fedora box. You can install a Fedora container on an Ubuntu box. And they will provide usable execution environments that you can install. You can do yum install HTTPD in your CentOS execution environment, and it will work, and it'll fire up, and it'll be perfectly functional. And then you can do apt-get update outside, and it'll work and be functional, and they won't see each other, they won't get in each other's way. So I'll give a little more demonstration of that once I get to the command line. So this is what Docker, that was what Docker does. That's kind of what it was designed for, what those design goals were. And this is why there's a lot of excitement. Is if you've ever fired up a VM, it takes a lot of disk, it takes a lot of memory, it takes a fair whack of CPU. I mean, not as much as it used to, but you're still talking about 5 to 15% or something on a lot of metrics. So it soaks up some of that capacity. It has all sorts of undesirable performance impacts. And Docker is really fast. Like you get your isolated environment in less than a second, and performance is bare metal. And I mean really fast, seriously fast. Like there is no difference running your app in Docker and outside of Docker. Like very fast. Now there are some things like the Union file system does give you a file system performance impact. There are ways around that. I'll talk about that a little bit and give a little bit of a demonstration of that, but I won't get into great detail because if you have those needs, you can work it out yourself from what I've demonstrated. But this, this is, sorry, I'm getting a little ahead of myself. This is quite fast compared to a lot of solutions you've seen. And then the other thing is that people are not reinventing the wheel as much as they needed to in the past. With Docker, you could really drive up your reusability. There's a lot of stuff, APIs have become an important thing. And the idea is that my company does food. And why do we have to have an email administrator or have to have a webmaster in order to do food. That's not our unique proposition. That's not where our talents are. So, you see a lot of, well, outsource your email, outsource your web services. And that's not because, it's lazy and so forth. It's like, we have a goal, we want to focus on this, and we'll just outsource the other stuff because that isn't our core competency. Well, Docker allows you to do that. You say, I'm writing apps, I don't really care about servers. Let somebody else design how a server got installed, and I'll just load my app into it and run. And so this reusability enables a lot of people to not have to dig into the weeds. Now, for some of us operational people, that's really scary because we're like, well, no miracles can happen in our systems. We need to be able to follow these bits all the way through. And that's true. But when you want to get stuff done, you start using abstractions because, well, at some point it's like, it works and I'll look at it if it's broken. And Docker allows you that capability, that you can kind of ignore a lot of complexity very easily. Oh, and as compared to virtualization, it's really, really cheap on disk and very cheap on memory too. I'd say that there's almost effectively no memory impact when it comes to running it. So if you're running 2 copies of Apache, one in one VM and one in the other VM, there's going to be a real cost because you're running 3 kernels and there's all the overhead with that. If you're running 2 copies of Apache on your computer and so you fire up one and maybe you copy it and you fire up another one and you'll see on a different port. The memory usage is nominally 2 times the amount one Apache uses. If you do the same thing in Docker, same thing. 2 times what one uses. There's overhead, but it's mostly a rounding error. And disks are far more efficient than other mechanisms because you're sharing with this AUFS stuff. You're sharing disks. The only disk overhead are the changes that are being made on each of these images. So if you've got largely the same baseline, you essentially deduplicate that information. Disk deduplication, but this is through layered file systems. I know you don't like AUFS.
Well, I'm just curious as to what the hit is. Deduplication can be very expensive.
It can. And
somebody's running random I/O.
Yep. I'm not arguing with that. So, but this is a lot faster than a lot of solutions for most problems that have existed before. So, one thing to point out is Docker is not the first kid to this game. So if you've used Solaris zones, BSD jails, or AIX WPARs, work partitions, that's containers. This is not a new idea. When I dug into this, I was a little embarrassed because I'm like, oh, my favorite operating system. You're way behind. People have been doing this for decades. Yeah, it's a little embarrassing. Linux is a little behind on that stuff, but it's catching up really fast. So even in Linux, in the Linux world, this isn't the first. There's something called LXC, and there's something called OpenVZ, and they pretty much are very similar to Docker. The functionality they deliver in that they provide isolated environments for things to run. But at least with LXC, they're really focused on simulating a whole operating system, not simulating an environment for just one program. So it's a lot heavier weight. You can get a lot of the Docker functionality out of LXC. And in fact, when Docker originally shipped, that was the underlying engine that drove it. They've now diverged from that and are starting to roll their own engine. But that was the engine that they were using. And also OpenVZ, which was kind of a special kernel that still exists. You can still see the project, there's still updates to it. And OpenVZ was way ahead of the game, quite a while ago, many years before Docker, who created this container idea on Linux where we isolate processes. But the catch was with OpenVZ, or Z, I'm an American, I'm going to say OpenVZ. Okay, when they created these isolations, what they did was they forked the kernel, and then they hacked up their version, and they followed along with the kernel patches. They keep up to date for a while. But they just ran as a separate branch. And then they're like, hey, kernel team, we've developed this really cool utility. Here's 50,000 lines of code. And the kernel team said, no. But if you break that up into 100 patches, we'll take it. And so what actually is interesting is a lot of the underlying stuff, the namespaces especially, the people who work on that are the same people who helped develop OpenVZ. So a lot of this technology is being fed into the kernel bit by bit by bit. And so it benefits a lot from the research done in that OpenVZ project. It benefits a lot from the work that was done in LXC, which when that came out, I just blew a gasket. I was like, this is so cool. This will solve problems. But I think Docker generally, in most cases, solves them better. Not always. So what does Docker look like? So here's your traditional virtualization. You have your hardware, your kernel, you have your hypervisor. This is your VMware or your KVM. And then you have a different kernel for each operating system. And you have your program running in each operating system. And what this looks like with Docker is that you have hardware, you have your kernel with all of these capabilities which have been developed over the last few years. And then you have this base image, and then you have your program, and you have this read-write layer that the program is living in on top of that. So this is kind of the process view that Docker has. This isn't the disk view. The container is that little shim between the image and the program. But this is kind of the view that Docker has. So you're doing a lot less overhead because you're not running these extra kernels and their operating systems. So a typical Docker run means download my base images, create a new container where I use that image as the base, insert that image in as the base, allocate a file system for read-writing on top of that so I can make changes if I need to, but those won't affect the base layer. Allocate a network stack that's independent of the base OS. Allocate a networking bridge so that I can talk to the internet if I need to. Set up IP addresses for inside the container. Execute the programs you want and capture the output. So that's what I'm going to show. Now that I'm done with my slides, let's get into the good stuff. So for my first trip, I'm going to build an Apache web server. And that's not a very exciting thing to do, but hey, this is what I do for a living, so be it. So let's CD, there's documents, KWLUG, Docker, and Docker. Okay, so actually, before I build Apache, I'm going to just give some small demos. So demo 1 is sandbox 1. And what I'm going to do is I'm going to reuse an image. So because the networking here is a little, not as fast as I didn't want to depend on it in case it went down or it was slow today or whatever. So I actually downloaded everything ahead of time. This is not how I would do it in production. But I've got all this data. So I've commented out lines, but this is how I got it originally. I said Docker pull Ubuntu, and it downloaded an execution environment that looks like Ubuntu, acts like Ubuntu. So now when I hit, I'm going to run this command, and what this command is saying is, and oh, by the way, I'm not covering installing Docker. If you're interested in using Docker, you're probably smart enough to figure out how to get it on your machine, so I'm not going to cover that. Sorry. If you need Docker, you'll know how to install it. So what I'm doing is I'm running the Docker command, and I'm saying, Docker, I would like to run an image. So I want to create a new container on top of an image. I want to run the image, so add the read-write layer and put stuff in it. And when I'm done, when this image exits, delete the read-write layer. Just get rid of it. I don't want to keep it around because this is just a demo. I don't need to keep it around. And when I fire up that image, I want to start it up in interactive mode, so I have a terminal connection to it, and I'm connected to it. And inside that image, once you've created this container, so once you run the image, it becomes a container, run bash. So I'm going to run bash in this container. I didn't copy that command right. So what you'll notice right now is that was my host name, TimX220, because I have a 220. And look at my host name now. I'm inside the container. If I do top, pig1 is bash, which I think is just kind of cool. If I do IP-ADDR, you'll see I have an ETH0, and there's this hardware address, 004B, and there's my IP address, and if I go over here, and I type IP-ADDR, you'll see that I have a lot more hardware network cards, and that the hardware address, I know it's small print, but I will assure you the hardware address does not match up. It's a different Ethernet 0. And in fact, if I do netstat route, I have a different routing table over here than if I did netstat route on the outside. Oh, no, yeah, the routing table is different. There's an extra entry over here. So I'm in an isolated environment, and I can do all sorts of stuff. I can do an apt-get, install, name something really tiny, stress. I'll install stress. Oh, actually, I need to do an apt-get update first, because this doesn't have any. So it's downloading packages, so it looks like I'm on a regular server, like it's behaving like an Ubuntu box. I'm actually going to cancel that because I don't want to wait for the networking. But I'm going to do something fun. And I know everybody's wanted to do this. RM, bin, and user. And let's throw out the recursive force. I will note, I am paying attention to what the host name is before I type this. So now I've just blown away all of the binaries in bin and user. Can't do ls. Can't run top, kind of screwed right now. But of course, when I exit out of the container, all my programs are still there. So it's kind of neat. Like I was in a virtual machine container, but I didn't damage the underlying OS. I think this is kind of a cool little trick. It's a party trick. I will concede that. But it starts to give you an idea of that isolation that exists. So the next thing I'm going to do, again, this is with an image that's already been downloaded, and I formatted this a little differently just so it's easier to read. So again, the same options. I'm going to run an image. I'm going to delete it after I run it. I'm going to run the Ubuntu image with the bin bash. But here I'm going to share a volume. So what I'm saying here is this directory right here, the directory that my presentation is in, I would like to mount that inside the Docker image on /mount as read-only. So it'll be in there, it'll be visible. You can mount it as read-write too. So now I can share some of the host disk, raw, untouched, to the Docker image. So it's not going through AUFS, it's just a plain, I believe it's called a bind mount, if I'm not mistaken. Oh, sorry, didn't copy my code. Let me just do that real quick. So let's just do that as another demonstration. And here I am in my image again. Look, no processes. And if I go to mount, I can see all of the demonstration code I'm running. And if I try to remove it, sandbox 1, can't do it. It's a read-only file system. Now, what you might use this for example, is you have your database software in some little execution environment, but you have your data stored outside of that container because you might want to upgrade your database. You might want to do a flash cut where you say, shut down this container, pop this one up with that database directory. Or you might do this with your web server where you're saying, okay, here's all the content, but don't touch this. Yep.
You're
run df minus h for me?
Yes. That's not my root file system. In fact, I'll pop over here, I'll do it. df minus h. Oh, actually, is it showing the same disk space? Maybe it's copying.
Same space.
It's showing the same disk space, yeah.
But
But it isn't the same file system.
But it showed CPU usage, even though it couldn't see processes.
Oh, actually, it's showing the file system twice. That's kind of neat.
So, is there a way to quota this instance?
Yeah, you can use the cgroup stuff for the standard disk accounting. I mean, these are normal processes. There's not much special about them. So, like, you can see them outside. You can apply the same kernel management mechanisms that exist otherwise. They will adhere to to those types of things. So, just kind of a neat demonstration.